Okay, so here's our setup. In this beaker right here, we see that we have boiling water. So when you guys come to class tomorrow, it probably won't be boiling. So your first step is to fill this thing up with a little bit of water, and then take one of your metals. Again, you're going to have this container right here. Okay, so this container right here is going to have 4 different metals in it. I already have one of those 4 metals in this this beaker right now. So one of these, the other 3 metals, you're going to have to do in lab tomorrow. Okay, so the one that's in here has already been warming up. Your job is to put a little water in here. You want to have just enough water to kind of cover up the metal, but not so much water that you fill the thing up. It purely is, it's a time issue, because if you have so much water in here, it just takes a lot more time to get this thing to boil. Okay, so put just enough water in to cover up your metal, and then get it running full speed ahead, 540 degrees Celsius, get it as hot as the plate will go. So this thing starts to warm up, because this has to get hot before you can do anything else. Once this is hot, it's boiling, it's ready to go, then you actually can start the experiment. Now, while this is heating up, the other thing you're going to do is take your graduated cylinder, and you're going to fill up somewhere between 50 and 60 milliliters of volume. Okay, 50 to 60. Okay, I think it tells you that in your actual lab sheet. So whatever volume this is that you measure, I had 57, looks like 57.0 milliliters. That goes in here. Okay. Now the graduate cylinder, you're done with that, so you don't need that anymore. You're going to have a lab quest out tomorrow. That's this little device you see sitting on there. It's also on the screen you guys see. That's the exact screen you're going to see tomorrow when you first start up the lab quest. Okay. So you notice how it's reading one temperature of 99.4 and one temperature of 16.5. The 16.5 is this one right now. Okay, so it's a probe that's not in the water. The 99.6 or 99.7 is this probe right here, and that's reading the temperature of the water that's boiling. But what temperature is this really measuring for us? The metal, right? Because we really don't care about the boiling water. That's just something to make things hot. So what we're doing is using this temperature probe to find out what temperature is this metal as it sits inside the hot water. Okay, that goes back to the zeroth law we talked about yesterday, that if I know the temperature of one thing, if it's next to the other thing and at equilibrium, which this here is, we know the temperature of both. So notice how I don't have the thermometer touching the bottom, because you want it kind of hanging out in the middle. So I know my temperature of the metal to start. Okay. I have my volume of water in here. This was 57 milliliters in here. And then I have another little half styrofoam cup. This is basically a calorimeter. They're called coffee cup calorimeters. So we got basically 2 coffee cups nestled together, and then another third one that I cut the top off it with a little hole in there. And you can just slide this in the hole, and that makes basically an insulated container for us. Okay. So now we're kind of ready to get going. We have our metal hot and boiling. We have our 57 milliliters of water in here. We have our temperature. So we're just going to go to the actual lab quest. And what I'm going to do, as you're working with this, you either can use your fingers. They are touchscreen. But there is also a little miniature stylus if you prefer to do that. I tend to like the stylus because I have fat fingers. So some of these buttons are kind of small. If you look on this, if you look on here, now I'm actually going to show it to you guys on the screen here, so you can see my cursor where I'm moving around, because I can control it this way too. You have different options. So your first option here, this is the main screen you're going to come to. If you click on the graph screen, that's going to move you over to where it's actually going to graph the information for you. If you want to see actual data, that's your XY. And then this is kind of like notes. You can type things in. So we probably won't use either of these icons. But we'll probably spend most of our time on this screen right here. So the one that looks like a graph, you'll click on that, get your graph up and running. You should see temperature 1 over here, temperature 2 right here, and we're doing our first run. So we're going to hit play, and as soon as we hit play, it's going to start collecting data. Okay, so I hit play, and we see data being collected in both temperature probes. Okay, we want to let this data collect for a few seconds so we get kind of a baseline, so we know what our starting temperatures are for both. Okay, and then once I have that ready to go, I need one more little tool. It's a very important tool for this experiment. It's a paper clip. And the paper clip I have bent so it makes a hook. What I'm going to use that for is to come in here and actually hook my metal. Okay. At this point, because I have a baseline of that red, that high temperature, I really don't need this temperature probe anymore. Okay, so I'm just going to take it out. I can leave it in there, I guess. And what I'm going to do, and here's the trick. This is why two people sometimes it's helpful. As fast as I can, I'm going to move the metal from here into here. Okay, and then I'm going to start swirling it right away. Okay, so there we go. Metal over here, into here. Unhook it, and then swirl. Okay. So the idea is, I want to now collect the data on what's going on inside of here. Okay. Does the red line really make a difference anymore? No. At this point, the red line really doesn't mean anything at all. Okay. So we're just going to kind of let that run and sit in there. It's not going to hurt anything. That's just going to just collecting data. And notice how I'm just sitting here and swirling this. And the idea is I'm trying to get all the metal's heat to be absorbed by the water, and then the water, give us some of the kind of go back and forth. And what we're trying to do is we're trying to establish that equilibrium between the two. So you guys watched in the video the other night that, as you put two things together, the energy that one loses has to be equal to the energy that the other one gains. So that's what we're doing right now, is that the energy that the metal is losing has to equal the energy that the water is gaining here. Okay, so I'm going to keep swirling until I get a really good, nice flat line at the top. This is set up to run for 180 seconds, so if you look at the bottom right there, we're at 142 seconds right now. So it's only going to run for 40 more seconds, even if I wanted to. So we'll let this run until it stops. You should have more than enough time, have it set up this way at 180 seconds, to basically collect data this way. Now, we know we have an efficient calorimeter because you notice how that blue line, it doesn't change, right? It's pretty much flat horizontal. If we had an inefficient calorimeter, it would get hot, it would spike, and then it would fade away over time. Because over time, what would happen is it would lose that heat energy. Okay, so as soon as we hit 180, notice how it stops collecting data, and our over by the cursor there, now it shows a play button again, because it's actually stopped the data. Okay, so we've stopped the data. We'll get this thing out of the way so it doesn't get hot. This no longer matters. Okay, this can kind of sit here, and then we have our data to basically analyze now. Okay, so the next step is, how do you analyze this data? Okay, I've done one metal. Your group is going to do 3 of them. Okay, so you need to do this experiment 3 times tomorrow. Okay, so you should have plenty of time for that. So let's go through and actually analyze the data now. Okay, so if we take a look, we have some different temperatures we want to work with. So first of all, we want to know the temperature of our metal to start, right? Where was that at? The metal to start was where? Is it exactly 100? It's somewhere in here, right? Okay. So originally, the metal was in the boiling hot water, right? So the metal was in here, so whatever the temperature of the boiling water was, that was our starting temperature of our metal. Okay? So our initial temperature of metal is somewhere along this line up here. Now, at this point right here, this is where we took the metal out. So we really don't want to deal with it here. We want to deal with it up here. So what we're going to do is we're just going to click, and we're going to highlight this section up here. Okay? And then we're going to analyze this section. Okay? It's actually going to give us 2 things. It's going to analyze the top line and the bottom line for us. So you want to find where it kind of flat lines out. See the flat line on both of them? Not in this little goofy area here where it kind of dips and that kind of stuff, because that's when you're moving the metal back and forth, and you kind of have a place where you're exposing that metal to the environment. So you want to kind of leave it like this. And then we're going to analyze it. So you highlight the data, click on Analyze, and what do you want? Well, we want some stats on that. Okay? It's going to ask you, well, what do you want stats on? I want stats on temperature. You have the red one, but I also want the stats on the blue line too. So we'll get them both. Now if you come over here, for channel 1, the red temperature, my stats are minimum is this, my maximum is that, my mean was this. Okay, standard deviation, took 91 samples. Which of these numbers do you think we should take? Yeah, the mean, okay? Because this should be one number, right? It was boiling the whole time. So we should take the mean here. So 99.5 is going to be our mean, okay? So you'd write that number down, okay? You could possibly put it in here, but let's just write it down. So we had... So the temperature initial for the metal is 99.5 degrees Celsius. Okay? That's what we got. That's our metal. So if we scroll down now, we can scroll down to, just click on the little down scroll. For temperature 2, down here, our temperature initial, or our mean, again, is 20.1. So the temperature initial for the water is equal to 20.1 degrees Celsius. Okay? Now we want to have some more information. So we don't want to analyze this part anymore. So we go up to Analyze, go to Stats, and then turn these off. And you do have to do it twice. It won't let you like click both at one time. Okay? So now we've turned that Analyze off. So instead, we want to analyze the ending point now, right? Okay. Are we going to analyze the red again? No. Okay? Because this only can give us the starting temperature of our metal. Okay? Instead, what we want to do is we want to analyze this part over here now. So I'm going to come over here, grab, and get this area in here. And again, I'm going to analyze. But in this case, all I want is the blue. Okay? Because the red really means nothing anymore because it was just sitting in boiling water. So let's go just to the blue, and let's take a look at our stats. Okay? So here, if you can imagine, what was going on is, as soon as this point hits right here, where my cursor is now, that's when the metal that was really hot got dumped into the water. So the metal actually went down, and it actually met right here and became part of this line. We don't see that because we can't actually measure the temperature of the metal directly. However, they were together in that calorimeter. They were inside of this calorimeter, so we know that the ending temperature, or the temperature final, is the same for both of them, right? Has to be the same. So let's find the final temperature. Okay. So here we have a minimum, a maximum, a mean. Do we want to do the average again? Yes? No? Yeah, you think so? Okay. That would be decent, but let's think about it. If this calorimeter loses energy over time, okay, let's say it isn't a completely a perfect insulator. Let's say, we're at 33, the room is closer to 19. So if this sits here long enough, won't this cool back down to 19 no matter what? Okay. It's a really good insulator. Double styrofoam cups works really well, but it's not perfect. So instead of getting the mean, probably want to look for what here? The max, yeah, okay. So we want to find the hottest it got. Let's use that number instead. Okay. So now, is there a big difference between our mean and our max? No. Okay. We had 33.5 and 33.6. If I didn't do this right over here, this little curve down part, it probably would have been the same number. So we're going to pull the maximum number here. Hopefully your data is as good tomorrow. We'll find out. So our maximum here is 33.6. So the final temperature for both is 33.6 degrees Celsius. Okay? So you now have all the temperatures you need. You know the mass of the water that you've used. You know that you're using lead. That's the metal that we have in this particular case. We have lead. And we're dealing with water. So we have everything we need now to set up our equation and solve. Okay? So that's where we're at. Okay? Questions on the procedure stuff for tomorrow? Okay. So then now let's go to the board and actually we'll do the math to solve for this one.